So, wait, I'll share the screen. So what we have covered, like in intro classes, what we have discussed. Anybody? Sad? Can you go with it?
I yet have to see the recordings because you start classes slightly late. I'm not able to catch up. So that's why I'll see the recordings
So,
next
okay.
time.
Going to sleep? No, no, what I'm asking is like charging. So just what you have, we have done with the last classes, give it that. Actually today, Zoom is loading, reinstalling. Okay. So we discussed about workflow. So then we discussed about, okay, and project architecture, what are the layers, what are the environments, and then we discussed about Snowflake architecture. Then we discussed about micro partitions, and now we are discussing about cluster key. See, we are discussing about cluster key. So today we will discuss about now cluster key. Then after I will revise what you have covered, like intro and what is a workflow, switch up workflow and the project architecture. So what are the tools we are using, and then I will revise everything. After this cluster key, then we'll move on. Okay. So here, so what is nature cluster key? What is the natural cluster key? Okay. So when you are learn anything, down switch on check. When you are learning about Snowflake, you need to go with behind what is happening in the Snowflake. Okay. So nowadays they are asking like interview questions, not like definition. Okay. Why many companies choosing the Snowflake? My why many companies choosing the Snowflake? Directly. Why many companies choosing the Snowflake? Okay. So why not other warehouses? Okay. What is the reason?
Sir, sir,
Yeah.
we will do cloud DBT or we will do core DBT.
Cloud DBT.
Okay, okay. So that means the 13 days trial.
Yeah, it will take for DBT Cloud 20 days.
Okay, so
Like
that means we have to do I mean, two accounts we have to create.
yeah, 3 to 4 for 4 weeks. I will share today date and syllabus. Okay, end of
And
the
sir,
day.
do we need like a debit card or credit card to open it, or just email we need to?
No, 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 no. For DBT, no need of credit card. Just you
Okay,
can create with your mail ID. But once you create only a Snowflake, you can create multiple times with same mail ID. But DBT only one time you can create. But it
okay,
is only 15 days, but we can use 1 year, more than 15 days. There is one option. We need to switch on that option after the 15 days. I will show you in the class.
okay.
Okay.
So Snowflake we can use the same ID, email ID.
Same and multiple accounts we can create.
Okay, got it, got it.
Yeah, multiple accounts. Multiple accounts we can create. Okay. So we are discussing about cluster key. So after this cluster key, I'm going to revise what we have covered like architecture, project flow. Only this inter class, still we have not created the account, Snowflake account. Okay. So tomorrow we're going to create a Snowflake account. And so nobody submitted the test. If it is submit, it will be difficult to get the job. Okay. So what I'm saying, uh, you need to go with the behind of learning while learning, not like definition, not like a code. Okay. Why many companies are choosing, why every employee they like transition to the Snowflake means because of its architecture and how it works, what is happening in the behind. Okay. New technologies, there is no layoff while you go with the Snowflake. Why? Because of inside we have the generative AI Snowflake Cortex. Okay. So what is nature cluster key? So nature cluster key is that by default physically organization of data inside the Snowflake table. By default, physically organization of data inside a Snowflake table. So when you load data into Snowflake, so we do not specify how it should be stored in the Snowflake. Snowflake automatically creates a micro partition and stores rows in the order they like received 1, 2, 3, 4 like utterance increment. So for example, suppose a banking system loads so transaction data. We have transaction data. So how it going to load into the Snowflake banking system? This so we're going to work on banking domain. Okay, banking. If you not understand, nobody, I will explain the project flow, then you will get it. So we are receiving the transaction data. Okay. Here for load time. So we're going to load time and transaction data. Transaction data. So here go with batch one. We have batch load, bulk load, incremental load, okay, continuous load, live data loading, near time live data loading. So we have different. So in batch one, we load it first of Jan and 2026, and then batch two. Okay, here it load second Jan 2026, like that. So batch three, then third Jan 2026. Again, batch four for 4th John 2026. So here what is happening? So each day we are receiving the data, right? So records are written into separate micro partitions. So first time I'm loading this batch one data. So this going to create separate micro partition for this one. Can give M1, and again uh, why it's getting like that means, so the data errors in the date order, right? So because of, so first January, so we are receiving this one batch one, second January this, third January and fourth January. So we are receiving data different dates. Okay, so the data arrives in date order. So each micro partition contains, so like a range of dates, we can call like professional, like a narrow range of dates. Like queries filtering by date can skip most partition. Reclustering is the excellent performance. Okay, I will explain why they are loading in different four partitions here. Suppose this is third one and this is fourth one. So people think like I'm loading batch one data, okay, batch one data, and then it's going to create micro partition, and I'm loading batch two data. So people think, so who don't know behind, uh, they think like, so when we load batch two data, it's going to rearrange the partition. No, not like that. It's not going to rearrange the partitions. It's going to create separate micro partitions. Okay, it's not going to, when we load and Jan second batch two data, it's not going to rearrange the micro partitions. It's going to create a new micro partitions. Why means, suppose if load batch one data, and on that same day, if you are receiving batch two data, it's going to rearrange the micro partition. Suppose I'm loading 100 records. Okay, same day after 1 hour, I'm receiving one more 150 records. Then it rearrange the partition. Rearrange. Why? Because of these 100 records and these 150 records, same date we are receiving, same date. Okay, like that. Suppose partition 1, 2, 3, 4. So in partition 1 we have the 1 million records. Okay, and it will have the also think like 1 million. Okay, if if both in the same partition, like it first I loaded this data 1 million, second I loaded this million, and third I loaded this one, and the fourth I loaded this one. Now these four are in the same micro partition. When you run like select star from table where account ID 721, it will scan all records, totally 4 million records. 4 million records. It means it will take the time and cost. And we have different dates. Suppose account ID, and I'm using where date like January 21st, or January, date like January 3rd. Then it will go. we're going to scan 4 million records. It will take the time and cost. Suppose if I have the 4 different partitions, okay, so now it will scan only this batch 3 because of I used account number and date John Todd. So the data is loaded on John Todd, right? So then it will scan only these partition and it will skip remaining 3 partition. So here what are the partition? So I will give for the new guys simple 1 lakh. Okay. So I have 1 lakh. I will take small number. I have 1 lakh records. 1 lakh records I have. 1 lakh records. Okay. Here 1 lakh records. 1 lakh is like one partition. One partition. Okay. And 1 to 25,000 partition 1. Partition 1 and 25,000 1 to 50,000 okay, partition 2 can call micro partition or micro partition 2 and then we have 50,000 1 to 75,000 partition 3 so partition 3 and 75,000 and Sam, are you there?
Yes.
Yeah, partition 4. Okay, so here now I'm running the one query here on this data for above one partition. Okay, so where I'm running, okay, select star from table name. So where account number equal to, so like I'm giving 721 and 821 as example. Okay, I'm giving the account number like this. So now what this query will do, how it going to work this query. Okay, so now I'm running this query on this partition, single partition. Here we have the 1 lakh records. Now it's going to scan one partition. Okay, it means it will take because we have 1 lakh, right? Suppose you have one book. Okay, so in that you have the 1,000 pages. You want to find some topic, but there is no index. What you do? You're going to open first, second, third, fourth page up to 1,000. You don't know where it is, which the topic is which in that page because of we do not have the indexes. Now you're going to like check every page, right? So then it will take the time. Okay, like that. Here we have the one partition. There is no index. There is no micro partition. Then it's going to scan 1 lakh records. Then single partition. So, or we can call without micro without micro partitions. So scans all data. So it take time and takes more cost. More cost. So this is without partition. So when we have divided it into the 4 partitions, so here I'm running the same query. Okay, now in the book we have the indexes. Now about below query, below data. So now when we have the indexes like 1 to 1,000 pages, there is start like a plus b whole square formula. Okay, we see the page number. Okay, then directly we can open it. So it will take 1 to 2 seconds to open that page. Okay, like that. While we have the indexes, now we have the 4 partitions. So while I run this select star table where account number 721,821, then it will going to scan. Okay, no, this is okay. It will think like okay, 74,821. Okay, so 74,008 we have this number, right? Okay, so now when we run this query, so it's going to scan only this partition. So third micro partition. dot micro partition. Then it's going to skip these two partition. So that is we need to call query pruning or partition pruning. Initially, we used to call query pruning, but nowadays in the documentation updated to the partition pruning. But both are same. Okay, here now while we running this query, it going to scan this one and it will skip remaining. Okay, so it scans only third, skips 1, 2, 4 partitions. Then okay, then query fast like no time. Okay, time is p few seconds, okay, and low cost. So this is the advantage of partition, low cost. So this concept is clear, right? What are the partitions? Speak out.
Yes.
This is clear, right? You write it down. Speak out.
Yes,
If
yes, clear.
not, yeah, if not understand, I will go with another example. Okay. So this is so how they going to ask interview questions on this topic. So first, they're going to tell them have you worked with indexes in the Snowflake. Okay. So remember this one. Have you worked with indexes? Okay, indexes in Snowflake. Okay. And this is one question. And second question of okay, is this one. So different type, same question, different type. How data okay, stores in Snowflake. Okay. And what are the micro partitions? Okay. And fourth one, okay, what is cluster key? I will explain what is cluster key. Okay. Okay. How okay, well, how we work with the index in Snowflake? No, indexes not support in the Snowflake. So indexes we have unique indexes. We have three types indexes that work in the Oracle SQL Server, not in the Snowflake. Indexes not support in the Snowflake. Instead of indexes, we have micro partitions and cluster key. How data stores in the Snowflake? The data stores in the Snowflake. The when we insert data into the table, the data going to store in the Snowflake in the format of micro partition in each field 50 to 500 MB. Okay, so it is a columnar format. It stores like metadata like minimum value, maximum value, row ID. Okay, and count of nulls. Okay, and duplicate values. It knows like everything metadata. So while running the query and the partition, so it's going to scan only relevant data. It's going to skip the irrelevant data. That is we can call query pruning. Okay. So like that we will explain. Okay. I will share that recording videos. You can watch it. Okay. There is like in depth. So same how data stores in the Snowflake. That question. What are the micro partitions? Okay. And what is the cluster key? And the data is mutable or immutable. The data in the Snowflake immutable. So I'll give one example. So one Ravi. Okay. And wait. ID name, salary, and the city. Okay. So it's name Ravi, and then salary is like 1 lakh. City is now Hyderabad. Then so he stays date. You can give the date also. No worries. Date is like May 21st, 2026. So he is in the Hyderabad current city. Okay. So what he got offer to in the some other company, you need to move the bank. So same data, you need to move the bank. So this is the data. Okay. So now what is data here? Here we have same data. So same data. So his salary got hike. Okay. And they need to move Bangalore. Bangalore. Okay. And then start like July 1st. Okay. Bangalore. So what is happening here? This value, okay, immutable. I'm saying immutable. So this going to, when we have the mutable data, replace this one. Going to overwrite this record. So this is first one, Hyderabad, and the second one, it's going to replace this record. So it's going to replace with this record. Updates, new updates. But in Snowflake, how it going to work? So in Snowflake, same he moved to Bangalore, that offer. So in Snowflake, it is going to see this record, first one, inactive. It's going to inactive and it's going to create a new record. You want to create new record, it's going to active. Why data is like immutable? So first one is mutable. It means it's going to overwrite the data. But here it's not overwriting. It's going to create new record, new row, and it's going to inactive and it's going to active. So why inactive means in Snowflake we have why immutable? Immutable data in Snowflake. So we have time travel and fail-safe features. So this is, it means fail-safe. It means, okay, I move to Bangalore. Okay, so there is a verification, documents verification on the Bangalore that from any company like TCS or IB. So then they will check with this company, right? Okay, when you are before coming to Bangalore, where you are living. Okay, they need to check with your data. Okay, you living in Hyderabad. What is your salary? Okay, 1 lakh. Okay, when you have last working day, so maybe July 20, 21st, right? July 20, the last working day. They go and check everything. Okay, so what is the percentage getting hiked? Okay, so those things they going to note, right? Previous data. Suppose if you have data is mutable, it's going to drop, right? This record going to drop. Then we cannot find about his details, background verification. We cannot find. But while we having this data like immutable, so we can going to have this inactive and this new record going to be new update data going to be active. Because of if any data is deleted from the table, so using time travel we can recover that 90 days. And the fail safe is other thing that we will see in the class. Okay, that will be done by the Snowflake engine. It's not we. Can't a Snowflake team. They go into Snowflake engine, then meeting, then discussion, then price and time discuss. Depend on desired. So what is the happen like? How that is happen, failed, so lost, depend. Okay, if simple, if any data is deleted, we can recover. If any data wrong updation, so if you any new fresher guy, if he deleted any data or any update, then if you want to compare old data with this new data, then we can recover the data up to 90 days plus 7 days done by the Snowflake engineers. That's why the data is immutable in the Snowflake. That's why the data is the immutable in the Snowflake. Okay, so come to here. Okay, that is like query pruning data. Okay, then how Snowflake organize the data by default means Snowflake stores the data in immutable micro partitions. So every micro partitions contains, okay, so every micro partition contains like column, okay, column data it will store, and it's a compression. You will compress the data and metadata. What is the metadata? Data of the data. Statistics about columns and table. And every column, okay, Snowflake records metadata. Okay, metadata like minimum value and maximum value. So number of district value. What is the district values means? Anybody? What is the district values?
Unique values which do not get repeated.
Yeah, unique. Good. So the every column, okay, every column. So it's going to store like metadata like this. So minimum value, I suppose I'm inserting one record in that 75,821 is the minimum value. Okay. and after I'm receiving new data, in that the data is 75,000. 7 to 1 is the minimum. First time receiving, it store the Snowflake stores. Okay, or 75,821 is the minimum value. When we run what is the minimum salary or some any number, so it won't scan the table directly. It goes to metadata. It gives the this value. Okay, first initially. So after some time, I have loaded another data that is the minimum value is changed now. So while loading the data, it going to check the Snowflake going to check, okay, if any data is less than of 75821, it's going to check and it's going to store like, okay, in the metadata, okay, 7571, this is new value and this is the minimum value. Now again, from the minimum value, now it's going to check the metadata, it's going to give the 75721 is the minimum value. Like that, same maximum value also. Okay, number of distinct, like how many unique values, number of null values, how many null values in the data. Okay. Mm, so we have done right. So we have things like micro-partition one having the column one
So,
and
what do you mean by null values? Null values will be empty values, but how in this case, why will it store null values? It does not mean
it's not
what's the
storing
logic?
it. No, it's not storing the null values. It's counting the how many null values. Suppose you are going to bank. Okay, you are applying. You are opening the bank account. You have given your name, not like must mobile number and email ID, everything you given your father name, mother name, and you are deposited something you get. But you not having the passport. You do not have the passport. That is going to be empty, right? So that going to null. So in the such a case, you are one person. There are 100 people. So like there are going to have million persons, millions. So in that million person, so like so 2 lakhs people have not have the passport. So now, if you want to know, so how many people, how many customers does not have the passport, then we can check with ready query. You can select a number of, okay, count of null values on that passport. Then we can check. It's going to store only now in that time. It's not going to scan the table directly. It's going to give the metadata. It means simple counting the null values. Clear? Just example I'm saying. Clear, right?
Yes, 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 yes.
Just checking, it only check the null values. Okay, it won't do anything. Why? Because while we are doing the performing some calculation, if we have the null values, it will throw the error. So that's why we need to handle we null like NVL, NVL2 plus we have the null handle functions. With that, we can handle the null values. Okay, so this is very. So it is like metadata only. While we are querying about these values, it won't scan the table from the metadata. It's going to give. So this is one advantage. Okay. Think like I give one example. So we have partition one, partition you can call right. So partition one we have like column. This is the column, and this is the min, and this is the max. So think like tax date, and then one John. Then think like this is maximum like 5th Jan. Okay, and here we're going to give like branch ID 101, okay, and 110. Then here we have amount, okay, 100, and here we have the 95,000. So same like we have the micro partition 2. So still we have not created the account. Tomorrow we're going to create the account after completing after revise. So think this is partition 2. Then here we have the tax date is 6th of June, and this 10th of John, sorry, John. Then here things like branch ID here take like double one, and this is take like 120. Then amount is like 200. Okay, and if this is like 88,000. So now what is happening? So if we query request, okay, if you are running the query, okay, we have to write. Okay, this is. So this is the remember this is the partition one. This is the partition two. So now here we take uh, if query request like transactions for January 8, 2026. So Snowflake checks the first metadata. Why metadata means while we're going to insert data, right? Date wise. Suppose day one, January 1st, some data, January 2, some data, January 3, some data, like that, right? So first it's going to check the if any query having like transactions for 8th January 2026, Snowflake going to check the metadata first. Why? Because of since micro-partition one, so only contain the dates up to 5th January. Here we won't have the we won't have only 1st to 5th January. But what's Snowflake going? It's going to skip this entirely. The complete partition one going to skip entire partition and it's going to scan partition 2. Why we have going to scan partition 2? Because of January 8th we have in this partition. Okay, so this is the we can call partition pruning or query pruning. Okay, partition pruning and query pruning. Rejoin with the same link. Okay, there is only one minute. Rejoin with the same link, everyone. Okay, so meeting on now rejoin same link now.